Right, final example on the uniform continuous distribution. The amount of time in minutes that the person must wait for a bus is represented by the probability density function. T is uniform between 0 and 15. What is the probability that the person waits fewer than 12.5 minutes? So let's just draw a little rectangular sketch. Let's go in between 0 and 15. Which means that is going to be 1/15. So the probability that the person waits fewer than 12.5 is that area there. So probability x is less than 12.5 is going to be 12.5 times 1/15. And that's equal to 5/6 or 0.83. B. On average, how long must a person wait? Well, the average is the expectation. The expectation is going to be 15 plus 0 is 15 divided by 2, which is 7.5 minutes. What's the standard deviation? Standard deviation is the square root of the variance. So first of all, work out the variance. 1/12 15 squared, b minus a squared. So that's 15 squared divided by 12, which is 18.75. So the standard deviation is the square root of that. 4.33. D. 90% of the time the person must wait, 90% of the time the time a person must wait falls below what value? So 90% of the time, so out of my rectangle here, what this is saying, the total area of that is 1 or 100%, excuse me. And I want to know at what value there, this area is 90% or 0.9. So what I'm trying to work out is the probability that t, this is a t function, not x, which I just noticed, is less than x. And I know that that probability is 0.9 for 90%. So this area is x to 0, so x times 1/15 is 0.9. So x is going to be 0.9 times 15, which is 13.5. So what that is saying then is 90% of the time a person has to wait no longer than 13.5 minutes. So that value of x there would be 13.5.